Hey, what's up, guys? This is Chung here. So today, I want to talk about this number 465 optimal account balancing problem here. This is a hard problem, but I think it's a very unique hard problem, something that I have never seen before. Okay, so let's take a look. So a group of friends went on holiday, blah, 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 and and someone's lent each other money. For example, Alice paid Bill this number, this amount of money is represented by the lender and the receiver and the amount of money. Okay, and then given like a list of transactions between a group of people, return the minimum number of transactions required to settle the debt. Okay. Mm. So, for example, people. Okay, sorry. So and there are a few like constraints here. First one, a transaction will be given as a tuple here. So X is the lender and Y is the receiver, Z is the amount. And the second one is a really interesting one. So basically the person's ID may not be linear. Okay, so which means, the X and Y may not be from 0, 1, 2, 3, 4, 5. It could be like a jump to any numbers here. Okay, it could be like 0 to 6. Okay, so that's something we need to keep in mind for now. Okay, so and it asks you to what it's asking you to do is return the minimum number of transactions required to settle the debt. Okay, how to settle the debt? Okay, so for example here, so now num people zero lent people one $10, and people two lent people zero $5 in order to settle all the debts, which means everyone has debt zero. Is the minimum transaction is two. So one way is to settle the debt is uh, so basically person zero will give person one $10, and person two will give person zero $5. Okay, so that's how we can. Okay, sorry, that's the explanation. I'm sorry. So is to per people one uh people one pays per give person zero $5 and also give person two $5. That's how we can settle the debt. Okay. Okay. I mean, it's a very interesting problem. At the beginning, I was thinking about, okay, this one seems like a graph problem. Basically, maybe it's a weighted graph problem. Basically, from 0 to 1, right? We have $10, and then from 2 to 0, 2 to 0, they're like $5. Okay, and but then the question becomes to like what's the meaning of all every person is settled with the debt. I mean, then I was like, shall I use like the in degrees or out degrees, right? But in that case, I mean, we have like basically, so it's just something like you just need to add like a different like edges, right? But to so that every node the integrate is zero, right? But that's something at least I didn't figure that out. I mean, I didn't find a way of solving this problem in terms of a graph way. So what it turned out to be the solution is we just need to use like the DFS or with the backtracking. Basically, we just need to try all the possible settlements. Okay, and then among all the possible settlements, we return the minimum one. Basically, every time when we make a settlement between two persons, we increase the transaction by one. And among all of those settlements, we return the minimum one. That's the DFS solution for this. But now the problem comes, another difficulty arises here. What's the base case? Okay, I mean, the base case is like the first one. The first difficulty for this problem is that what's the base case? So the base case is all the person's stat is 0. I think that's not that hard to come up with, right? But the second one is that how can we do the settlement? Let's say if we have like one of the settlements, okay, and let's say one person have a debt like equals to 5, and the other one has a debt like equals to -5. I'm sorry, -10. Okay, D1 and D2. So I mean, so the settlement is like so our approach is every time when we have like two person that we can settle between them, like we just like use the current one. We basically we settle one to the other. Basically, what we're trying to do is we're always trying to make the current one, the current person's like to be settled, which means let's say if the current person is D1, whose stat is 5, we're always trying to give this 5 to another person whose the stat is negative, which means after the settlement, our current person will have that 0. Okay? So in that case, we can simply like uh, ignore the current person and then we move to the next one. Okay? And then we keep doing it until all the persons are settled. Okay, the tricky part for this problem is that how can we move our cursor uh, forward? Okay, basically, like I said, the way we're moving the cursor forward is that every time when we have like a current person, let's say it's 5, and then we find another person who's like that is negative, then it means that we can like cancel each other's stats. Okay. In that case, we always try to make the current person's stat equals to 0, which means we'll move this stat to that person. Okay, and then we just move to the next person because the current one is 0. Uh, yeah, I think that's the basic idea, but I think there's still a lot of things that haven't really talked through. So let me try to explain a little bit more while I'm coding here. So like I said, and we're gonna have like a that's here. Okay, so we're gonna initialize the dat first. Okay, so sorry, it's the int. So the way we are doing the dat here is like pretty straightforward. So we have a from and to, okay, and then the amount, okay, from in the transactions, okay, and then for the dats, you can either do it a plus or so I think for the current one, so the dats means the if you're giving the money, if the for the from the debts is negative or either positive or negative is fine. It doesn't really matter because for me, I think the debt is negative for the lender, which means we're gonna decrease that amount from the lender, and uh, we'll also need to increase the amount for the receiver. That's how we define the debts, okay? And after this, right, it means some people's the debt they may have already been 0, right? So for those peoples, we can simply ignore them. So that's why we do a simple like a removal for for people whose stat is 0, and also for the note number 2 here, since the the key here it could be not non-linear. So for that, in that case, I mean, it will be a little hard for us to when we do the backtracking because let's say we are at number people 2 here, like say for example 2 here, and then the next one is 6 in our debts here. But how can we from 2? How can we find 6? Because the map is not like it's not sorted. Okay, I mean unless we sort the map. I think we can sort the map, but uh, yeah, I think we can also sort the map, and then we just find the next one, or we can just convert like this a map into a list. Okay, so I'm gonna convert that to a list here. So basically, the way I'm converting to a list is I'm gonna be after converting the list, the index will be the ID of this person. Okay, and yeah, so that's uh, that's a person's ID. Okay, for ID in DATS. Okay, if the DATS is not 0. Okay, basically that's how it works, right? Basically, we're trying to get each of the DATS out of the map here. If anyone is not 0, we just insert it into like the DATS list here. Sorry, DATS list. Oops. So after this one, we have a DATS list, right, with like the index to be the key of that person. Okay, because we don't care about what's the original ID of that person, because we are simply trying to get the minimum number of transactions. So the ID doesn't really make too much sense to us. Okay. Now the backtracking here, and okay, let's try to do a length of the that's list. Okay. Now the backtracking. So actually, so the backtracking is that we're gonna have like the index here. So which means the index is to us is like the persons. Okay. And then and in the end, we simply return the backtracking uh, if we're starting from 0. Okay. And so what's gonna be our like our ending point? Okay. So the ending point is the okay. And one thing to remember here is that every time when we are at index here, we are assuming that from 0 to index -1 are all settled. Okay, which means like everything's before index have already been settled. So all we need to check is if starting from the index is if there's any that has not been settled. Okay, so here's how we check that. Well, the index is smaller than n, right? And the depth of index is equal to 0. And then we increase the index up by 1. Okay, and when the index is equal to the n, then we know, okay, everything's settled. We can simply return 0 here. So why is that? Because we are later on we're using this return value. Okay, so the system dot max size. Okay, and now and also the way we're doing this is that we find, so after this, right, after the while loop, and if there's still some that has not been settled, now the current index is the first that has not been settled before. So that's why we need to check what are the other what's the counterpart that can settle our debt. Okay, so the way we're doing it is that since everything before ID before the index, they're all settled, right? Which means their debt is 0. So which means we only need to look for from the current index +1 to n. And what's the and okay, so and if we just need to find like a debt with opposite signal here, right? So which means if the debts of the index of I, or the index times debts of the I is smaller than 0, okay, then it means that okay, we find like another debt to settle. Because why we're doing this, because let's say if some I here is it's 0, okay, it's 0, it means that there's no point to settle with that person, because that will definitely give us like a higher number of transactions, right? Because let's say if we have 5 here and we have 0 and then we have a -10 here, I mean, let's say this is current index, okay? And this is I, this is also I here. I mean, it doesn't make sense, right, to try to transfer the 5 to 0 here, because if you do that, right, I mean, basically it's wasting one transaction. We're wasting one transactions. We're not settling anything. We're simply transferring the money. Basically, we're settling this one person, but we're making one already settled person to an unsettled state. So that's why we just need to find like persons that has like a negative that here, so that, I mean, basically, so it's a one shot, it's a one stone two birds, right? We're settling this one person's here, and we are also like making this person's settle. I mean, it's possible. Let's say if this one is like negative 1 here, okay, and after giving like this 5 to the 1 here, so this is 0, this becomes to 4, okay. But still, right? Still, we are trying to settle the other persons, because another thing is that if this person has like a not negative, let's say this person have like a positive 10 here, it doesn't make sense to settle this person to this person, right? Because after giving this person, if after settling this 5 here, I mean, this person's stat will be basically increasing more and more. So I think here is like a little bit like a greedy intuition here. Basically, we're finding the negative, the opposite that to settle the current one. Okay, that's kind of like our best move here. And since we have like among all those like i's here from the index 1 plus n here, basically we will try all the possible like that whose uh the amount has a different, it's like has a different signals of the current debts. Okay, and like I said, the way we're doing the settling is we're always settle the current persons, which means after this settlement, this debts index x will become to 0. Okay, so which means no, so which means that current debts of I will become to the debts or plus the debts of index. Okay, and then right, because the current debt is now it's gone, and after the settlement, right, the debts of the index will become 0, and the debts of I will become to the debts of I plus the debts of index. Basically, we're moving the amount from the debts of index to the debts of I. So which means after that, I mean, the current index has already been settled, and we just need to look for the index plus 1 position. Okay, so backtrack, sorry, index plus 1, and don't forget to plus 1 here. This plus 1 means that one transaction. Okay, so that's why we do. And also remember, since we have like a for loop here, and and every backtracking recursion calls sharing the same debts array here. So which means after this call here, we need to set this debts back to its original amount, so that the next for loop will have like a clean state of this debts array here. Okay, and in the end, we simply return the answer. Cool. Oh, actually, sorry. I mean, so from here onwards, we should start using this list here, not the original debts here. That's why I need to copy everything here. Cool. Yeah, I think that should be it. Let's try to run the code here. Damn. Uh, built-in function. Oh, sorry. IDX. Cool. So this one passed. Let's try to submit. Cool. So it accepted it, but it's not that fast. But I think this is kind of, at least it works, right? I mean, for the hard problem, I know we first we were trying to make it work, right? Again, so just to recap this problem real quick. From here onward, from up to here, it's pretty straightforward. Basically, at this moment, we have like a debts of a list of debts, right? Which have like different numbers, like number a -5, number -10, 4, -1, blah blah blah. Okay. Actually, from here onward, we can. It's like just as if we're having like a different arrays here, right? With different numbers here, and and then we're and then we're being asked to just to actually to do any of the transactions. Okay, basically we're allowed to move some numbers move from some numbers from one location to another, right? So that and then we're asked to find the minimum transactions, right? So that after those minimum transactions, all the numbers on this in this array are becoming to 0, right? So this is the same problem of this problem here, right? To do that, right? We are like basically we're trying all the solutions, all the possible combinations, but with a little bit of a strategy here, okay? And so so the first thing is the what the I think the most important idea here is that every time when we try to settle like the current number here, right? Basically, first, if this one is an active, and basically we're trying to settle this one with all the positive numbers here. And the way we're doing the settlement is we always try to make the current one balanced. Okay, basically on each movement, if this one is 0, okay. So whoever has the settlement later on is being calculated here. But and after this settlement, at least the current index, the current position is settled, so that we can just move the index to the next one, okay, until all the numbers have been settled. I mean, the 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 nice part for this thing is that once we settle the current one, we know that everything before this one is already settled, okay, and so that's the first part to be careful. And the second one is that our ending point, okay, and so we know that, right? We know that mm, let's see. And another thing is that, for this part, right, basically so why we're doing the while here, because, the reason being is that let's say we have like, let's say we have a 5, uh, 5, 5, okay? And then, we have like -5 and a -5, okay? So, so we're at this one here, and then we're finding the first one to settle, right? So now after settlements, so the index is the index, okay? And after the first settlement, this one becomes 0, and this one is 0. That's why we move the cursor, the index to this one. Okay, now this is the index here, and now for this one, after this one, this is 0 and this is 0. Now we're at this one here. So what this one means, it means that, okay, so at this moment, the index, right? So the current index is already 0, which means that Actually, at this moment, everything is settled. Okay. Mm. So what I think what kind of makes sense is that instead of doing the while here, we can always do this, right? We can always do a basically instead of doing the while here, we can do this, right? Like I mean, basically if the current index, right? If the current index is uh if the index is smaller than n, right? And the index is if that's the current one, it's already settled, okay? It's zero, okay? In this case, what do? We can simply like uh uh we can simply return, right? We can simply return the backtrack of the index plus one, okay? Because we're not settling everything. I think this should also work if I'm not mistaken. Nah. Hmm. Okay. Hmm. Let's see. I mean, I think okay. So here, I think I should. Sorry, I should have used the stats list here. Yeah, I think this should also work. I mean, yeah, but it's even slower because we are like doing like some like unnecessary backtracking calls. That's why basically anyway, you guys get the idea here, right? Because the reason we're doing like a while loop here is that we're trying to skip. We're trying to simulate this like these two lines here. Basically, as long as if the current one is zero, it means that we don't have to settle the current one, right? We can just do the backtracking and pass it to the try to settle the next one until we have settled everything. We're doing the while loop here just to save a few recursion calls for those like zeros, so that we don't have to waste time there. Yeah, yeah. I mean that's the idea here, and also like I said, I mean, someone may have asked, okay, so once you settle this that's I here, how about that's list index here, right? Why didn't you change the value of this one? Basically, I mean, ideally, right? Ideally, I mean, after you settle this one, you increase the debts for the current one. You should also decrease the debts for the from this current index, right? But like I said, you know, since we're always trying to settle the current index here, okay? Let's say we have a like negative, for example, this one, negative 5, 10, and the negative 5 here, okay? Sorry. So after the first settlement, right, now based on our code here, I mean, this is the current index, and now this one will become to 5, okay? But we didn't change, I mean, we didn't change this like negative 5 to 0. I mean, although we can, but it not necessary, right? I mean, ideally, right, after settling these things to negative 5 to 5, right? So this thing has to be needs to become like 0, right? But since we're always moving like the index forward and we're assuming everything like everything before the index has been settled, that's why we can save, right? Basically, we can save the time to check anything that before index. Otherwise, you know, otherwise every time when we do the final for loop here, we have to check everything. We have to check from 0 to the end. That will be too much of the time, the time consuming, right? So that I mean that's why from here I only change the next one because I know the current one has already become to 0 and will never look back to this one. Basically, we're assuming this thing is already settled. Okay, and same thing for this, right? Now we're at index here, and this one is 5. Now we're trying to settle with the next one. This one will this now this one become to 0. But here it's still 5. We're not changing this one 5 to 0 because we are always looking forward. Yeah, okay. I think I have already talked too much because I just want to emphasize the emphasize the this unique like way of tracking the settlements among different numbers here. Basically, we're always looking forward, and we're assuming the current one is settled. That's why we can safely moving forward. Cool. Okay, guys, thank you so much for watching the videos and stay tuned. Oh, how about the time complexity? And the time complexity is this is n, right? And for the backtracking, right? For the backtracking, it's from the first one we are like looping through everything to the end. I mean, the worst case scenario, right? I mean, it's the worst case scenario is O(n) square. Basically, every time when we are at like this like the first one, we'll always find the last one to be our like counterparts. So that's why I think the time complexity is like O(n) square. Okay, and space complexity is O of n, right? Because we're only maintaining like these stats here. Cool. I think that's it. Thank you so much. All right. Stay tuned, guys. See you guys soon. Bye bye.